Hello students, welcome to Spectra Education Academy. In this video, I'll continue explanation for short answer type questions from the chapter Wave Optics. Let us see the first question. Does the principle of conservation of energy hold for both interference and diffraction phenomena? So explain it briefly. In case of interference, in case of interference, the there is a loss of energy at the positions where dark bands are formed on the screen, and this is reappear in at the positions of bright band. So this is how you have to write it. In case of interference, in case of interference, the energy disappear, energy disappear at the positions, at the positions of dark bands, at the positions of dark bands on the screen. Whereas this disappearance or this loss reappears, this disappearance or loss reappears. This disappearance or loss of energy reappear at the positions of dark bands, at the positions of bright bands. Therefore, there is no loss and there is no gain. Therefore, law of conservation of energy holds good in case of interference. In case of interference. Whereas in case of diffraction, in case of diffraction, in case of diffraction, in case of diffraction, interference takes place. Interference takes place. Interference of particularly secondary wavelets. Interference of secondary wavelets takes place. So therefore, total energy remains constant. Therefore, total energy remain constant. It's in both interference and diffraction. In both interference and diffraction, the energy redistribution takes place. The energy redistribution takes place. The energy which disappears at the positions of dark bands reappears at the positions of bright bands. So the energy which disappear at the positions of at the positions of dark bands reappear at the positions of bright bands. So therefore, law of conservation of energy holds good both in case of interference and diffraction. Let us continue explanation for the second question. Question is, how do you determine the resolving power of your eye? So the explanation is, take some black strips of equal width. So that too approximately 0.5 millimeters. So let us say these are the black strips. These are the black strips. These are the black strips and say equal width. But you leave the gap 0.5. Let us say this is approximately, this is the first black strip. Between consecutive black strips, you are leaving a gap of 0.5, 1, yeah. So understand that this gap is 0.5. So strip ka width is again 0.5 millimeters. Now even this strip width is also 0.5. But you increase the gap. Let us say this is a black strip. Between any two black strips, there is a gap. So this is gap. Now take another black strip, leaving the gap more. Say this gap is 1 millimeter. Say this gap is 1 millimeter. But the width of the strip, black strip is again 0.5 only. Yeah, so take another black strip, but you leave more gap here. Relatively more gap. So this is 1.5 and so on. So this is 0.5 again. So this is again black strip. Right. So explanation is, take black strips of equal width, roughly 0.5 mm. Paste them on a whiteboard, leaving the gap of the order 0.5 millimeter, 1 millimeter, 1.5 millimeter, so on, between consecutive black strips. Now, after this, hang the hang the whiteboard, on the wall. See the black strips. By standing, at the larger distances, from the wall, you will notice that all black strips are merged all black strips are merged and appears as a single band and appears as a single band and appear as a single band. When you move closer, when you move closer to the wall, so this is all you need to practice by closing one of your eye. When you move closer to the wall, you will notice that there is some gap. There is some gap between black strips. Between black strips. And finally, how do you determine your resolving power means? Understand that distance between you and the board, so which is hanged over the wall, is capital D. Say, let it D be the distance between the observer and the strips which are pasted to the board, and board is hanged over the wall. Capital D is the distance between the observer and the strips, and small d is the distance between any two black strips. And so resolving power theta equal to small d by capital D. So using this formula, you can resolve. Thank you very much, students, for watching my video. But don't forget to share and subscribe with your friends and relatives. Thank you very much.